Hello and welcome to R&D Maths. Today I'm going to give you hints for 5.3. So in 5.3, first question, actually the first thing here, there is a typo. There is a typo here. It shouldn't be x5, it should be let x be the, or let x equal. So let x be the amount of. And then, yeah. So this problem, first of all, it belongs to 10.3. So I have opened my slides here as well. Now let me go to 10.3. Now in these slides, yeah, it explains all the, yeah, you will be using this. And again, this idea of degree of freedom. And the table 7, that is something you must need. And here, I recommend you to, give me a second here, guys. Yeah. Now, I recommend you going through this example and working it first. So it is exactly similar to your 5.3a question. Now let me go back to that one. So in this question, what you actually need to do is first use 5% level to test. So that means alpha level of significance is going to be 0.05, right? That's the first thing you need to understand, level of significance. And then you have to set up your H0 and H1, null hypothesis and alternate hypothesis. So reading, compare it with this one in this, see here in this example, how they are setting it like that. You have to do it for your example. Well, it may not be, it can be in words, it can be in equation. So please set that up first. And then what you need to actually see, actually this is, in this case, sigma squared going to be 5776. That's going to be the null hypothesis, right? See, I helped you. Now this one is going to be, read this sentence, then you'll understand greater than or less than that statement. Now we are going to test this claim. Now what you actually need to do, find what you need to do, find chi squared using this formula, which is explained in the slides, s squared over sigma squared. Now n is the number which is clear. S and sigma in this case squared are nicely given in this simple example. So you find that out, you will get a certain value, right? Then the next step is find degree of freedom. That's going to be n minus 1. Again, pretty simple, find that out. Next, what you need to do, use these two values and table 7. Now let me explain quickly this. Let me see. Using this example, see in this example, 12.24 and 24. Remember that. So 12.24 and 24, and then you have to go here. So how do you go there? By table 7. Now let me go. Let's see if I have. Yeah, I have here. See, table, yeah. Again, if you have the book, no, that's table 8, so probably, yeah, table 7. See, so what was the values? I forgot that. 12.24 and 24. So DF, degree of freedom, is 24 and 12.24. And also something to note here in this example, let me see here. In this one, actually, give me a second. See, this is important. Left tail test. Now you have to understand in your question, because of it says less than, and you have to understand whether we are going to use left tail test or right tail test. Now, so I'm helping you. You just fill the gaps, right? Understand this and clearly fill the gaps. So now let's go to this one here. 12.24 and 24. Now let me go to the table. 24 is the here. I look at the cursor here. 24. That's the DF, degree of freedom, and 12.24. See, 12.4, and so between these two numbers, right? Between these two numbers, that means over here 9. Sorry about that. I don't know what happened. Okay, 0.999 and 9.975. Now let's go back. See, 0.999 and 0.975. Why 1 minus? Because it's left tail. If it were right tail, it's just that value, right? So you do the same thing using, come on, sorry guys, this thing is stuck again. Give me a second. Okay, I think I'm back, right? Yeah. So what you need to do, use your values and table 7 and find the p-value. Here some value, here some value. So that's going to be your answer. That's going to be your p-value. Now, depending on that p-value, whether p-value and your level of significance, for example, if your p-value lies below, when you draw a number line, and if you're 0.05 here and the interval you are getting is over here, then you have to reject, right? That is the idea. Now, next one, find a 90% confidence interval. Now, for that, what you need to do, let me show you here. For that, what you need to do is, keep reading slide and you'll understand. Let me show you the exact place that you need to actually see. This one is exactly what you are looking for where these chi squared u and chi squared l upper and lower things are actually this one is the important one. So chi squared u is the value from table 7 using the degree of freedom n-1 and right tail area 1 minus c over 2. So that's the part you need to remember, 1 minus c over 2 and 1 plus c over 2. Now let me come over here. Now in your problem, let me erase some parts here. So in this one, now this is for part B, guys. For part B, what you need to do, so for chi u squared, that is chi squared value from table 7 with df equals n-1 and right tail area. In both cases, it's right tail area 1 minus c over 2. Now, what is c? In this case, c is actually 0.9. Why? Because 90% confidence interval. Now, using that, 1 minus c is, so 1 minus 0.9 over 2, you find that value. And then what you need to do, find that value, using that value and this value df, exactly like you did before here using table 7, you find value chi u squared. And similarly, chi l squared, same thing, right tail area, but this time 1 plus c over 2. So find that value using that and the degree of freedom, go to the table number 7, find that what you are getting here is you get two values for chi l, chi mu and chi l, and then you use this formula n-1 s squared over chi u squared and n-1 s squared over chi l squared. Now let me show you in this one. See, so this example number 4, please read that and understand it before you do 5.1b. So here, see chi, now here degree of, it's not 95%, so 0.95, and then sample size n 30, so this is 29, and then you find chi mu using table 7 and this value, you get this one, right? And for the other one, you get this one. So see this part I wrote. So those two values, you write it over here and you find your interval. That is pretty much part B. So if you read those two examples, that's going to be pretty easy. Now let's go to next one. Question number 2, well, the same story, but there are some typos I need to address. First of all, first question should be, what is the level of significance? See, you have what is the level of significance, but it's repeating here, you don't need that. And find or estimate, if say this is, you don't need that because here it's done. So it's some typos, I mean too much information. And also, since you did this on first one, you don't need this. So just find the level of significance. That's pretty easy because it's say here, then 0.05. State null and alternate hypothesis. Well, I will leave that to you, right, to figure out. So in this case, I mean, I can give you a hint. So H naught is going to be, what does it say? So claim variance for collages and universities is greater than. So first of for the null hypothesis, you have to make it equal. So sigma squared going to be 47.1. That's the null hypothesis. And alternate hypothesis is, well, think about it, right? See, think about it. So how do you write it down? H1. You don't write H1 equals, let me H1 colon, you may have to use this or this, whatever, figure that out, guys, right? And then find the value of chi-square statistic. What are the degree of freedom? So exactly same thing that you did before in your last question. So chi-squared, that's going to be n minus 1 squared s squared over sigma squared. Now, well, you have a tricky place here because see, in the question it's giving you s and s, but what are you going to use? So sigma squared, well, see here, so that's sigma squared. So s, in this case, what is s? Is it this or this? Figure that out. Read this carefully, what it is asking. So figure that out. That's easy. And find, well, exactly the same thing. So you find this value and then you find df value. Use those two together with table 7 to find this. So again, you have to understand whether this is right tail or left tail. Depending on that, there is, right tail or left tail that plays a role here. And then you give your conclusion. So exactly as like first question. Now, yeah, and 10 point, let me see, 10 point, do I have? Yeah, 10.3. Well, let me explain it here. 10.3 actually, this belongs to, so not 10.3, 5.3, question number 3. This actually belongs to 10.1. So I already explained it. So watch my last video for hints. What you need to do, let me quickly again to find chi-square. This time you have to use that formula, sigma, remember, O minus E squared over E. Well, sigma, so you have to sum. How many sums? You have how many cells? 1, 2, 3, 4, 5, 6. So you have 12 cells. So it's going to be like this, 12 numbers. Each number O minus E squared over E. So I recommend you to find this value separately for each cell. Let me help you for first cell. So for first cell, O minus E squared over E, that's going to be, well, O observed frequency, that's 64. What is E? Now, how do you find E? Now, let me explain. E, remember, that's, what was it? E, row total times column total divided by sample size. Now, what you get here is E, row total 96. See, for that row, that's 96. For that column, that's 289. So 289 divide by 519. Now you need a calculator, right? Well, you can do it without the calculator, but it will take time. And you, let me see, 96 multiplied by 289 divided by 49. So I'm getting 50, when I round it, 53.46, let's say that. So O minus C, 53.46, square that, divide by 53.46. That is the first value right here. Like that, you do it for all the 12 and then you get chi-squared. And then what? Then find df, degree of freedom. Now this time you don't use n minus 1 formula. This time you use row minus 1, column minus 1, the formula we used in 10.1, which is pretty easy. 4 minus 1 and 3 minus 1, that's 6. And then using that value, that whatever the value and this value, go to table 7 and the same story, right? I think that's enough help for 5.3, and see you in unit 6 video. Thank you.